the James Webb Telescope, and the mirror universe. Are we witnessing a multiversal awakening? It is possible that the universe we perceive is only a part of a much larger multiverse. In this larger universe, there could be many copies of us living in other worlds. Stephen Hawking. This statement from the late Stephen Hawking once seemed like abstract speculation, the musings of a brilliant mind on the edges of science and philosophy. But what if these words are no longer just theoretical? What if we are, right now, witnessing the first real evidence of a mirror universe? What if the James Webb Space Telescope, humanity's most powerful eye into the cosmos, has detected something so profound that it challenges the very fabric of reality? The latest findings may have cracked open a door, not just to the distant past, but to another world entirely. We are being pulled into a new dimension of thought, of science, of consciousness, and it might just mean the end of science as we know it. The beginning of the puzzle, a summer of revelation. It began in the summer of 2022, when NASA revealed the first deep-field images captured by the James Webb Space Telescope. To the untrained eye, the image was stunning. A rich tapestry of stars and galaxies stretching across the velvet darkness of space. But to scientists, it was something more, a crack in the cosmic code. The image showed galaxies that shouldn't exist, not just because of where they were, but because of when they were. Webb had spotted clusters of mature, fully formed galaxies at a time when, according to all conventional cosmological models, galaxies shouldn't have existed at all. Take the galaxy glass, Z13, for example. Based on its redshift, Z equals 13. It dates back roughly 13.5 billion years, placing just 300 million years after the Big Bang. But this galaxy wasn't a chaotic cloud of gas and dust. It was organized, luminous, structured, a sign of evolution that, by all previous estimates, would have required at least 1 billion years to form. Then came Maisie's galaxy, discovered at an even earlier point, around 200 million years post-Big Bang. And most astonishingly, a galaxy candidate known as F200 dBTZF045 showed a redshift of Z is almost equal to 20.4, implying it formed a mere 168 million years after the Big Bang. These galaxies weren't anomalies. They were just the beginning, a fundamental paradox. Why the impossible galaxies matter. How can something be older than the universe itself? This is the paradox at the heart of the crisis. According to all established physics, stars could not have formed until at least 500 million years after the Big Bang. Galaxies? Even later. But Webb's data says otherwise. These galaxies weren't just forming. They were already well developed. There are only a few possible explanations. The universe is older than we thought. Our physics is incomplete or flat out wrong. We are looking at something beyond our universe entirely. That third possibility is where things get wild. Some researchers now speculate that these so-called impossible galaxies may be the first observational evidence of a mirror universe, a counterworld, governed by similar physical laws, but evolving on a different timeline, or perhaps loop back in time. Understanding time through light, the cosmic time machine. Let's take a moment to understand how we see the universe. Light travels at a fixed speed. The farther away an object is, the longer its light takes to reach us. When we observe galaxies that are 13.5 billion light years away, we are literally seeing into the past, watching them as they were billions of years ago. Even Alpha Centauri, our nearest star system, is seen as it was 4.3 years ago. In a very real sense, all astronomy is archaeology, digging into the layers of time to the photons that reach our telescopes. James Webb doesn't just take pretty pictures. It analyzes the spectrum of light, calculating its redshift. The more the light has stretched due to cosmic expansion, the older and farther the source galaxy. That's how we know how old these galaxies are and why their very existence is so shocking. A multiverse in the shadows? The return of mirror universe theories. If we cannot explain these galaxies using the Big Bang model, dark energy, cosmic inflation, or classical physics, what then? One compelling answer is that we're not just seeing our own universe. We're seeing across a cosmic boundary, a threshold between our universe and its mirror counterpart. In this mirror universe, time may flow differently, and structure may have evolved at an accelerated rate. Or perhaps, like two opposing streams in hourglass, the universes were born simultaneously, one expanding forward in time, the other backward. In quantum physics, the idea of multiple realities is not new. The famous Schrödinger's cat thought experiment suggests that reality exists in multiple states until observed. Apply that to galaxies, and you might just get Schrödinger's galaxy, a real galaxy observed by Webb that appears to exist in two different locations, showing contradictory redshifts. Astronomers jokingly named it after Schrödinger's cat, but the implications are no joke. Theories on the rise, from starbursts to the cyclical universe. Faced with these paradoxes, cosmologists have proposed a range of explanations. Starburst theory. Perhaps in the early universe, star formation happened at a blinding pace in unusually dense regions. But this alone doesn't explain the structure and mass of the galaxies observed. Modified age models. Some researchers suggest that the universe is far older than 13.8 billion years, maybe 26.7 or even 40 billion years. These estimates use alternative physics like the tired light theory, but they come with complications of their own. Roger Penrose's conformal cyclic cosmology. Here, the universe is eternal, cycling through infinite eons. Each Big Bang is not the beginning of time, but a rebirth from a previous cosmos. Structures like black holes, or even galaxies, could survive this transition. The Webb findings might fit perfectly into this theory. Each theory attempts to explain part of the puzzle, but none can fully account for what we're seeing. The latest shock, a new deep image and more evidence. Roughly a year after the first deep image, Webb trained its lenses on another patch of sky, this time in a different region. Scientists hoped to see something different. What they saw instead confirmed their worst, or most thrilling, suspicions. Again, Webb detected rows of galaxies that were too old, too structured, and too numerous to be explained by our current physics. Worse still, or better, this image revealed an unprecedented structure hiding behind the Pandora cluster, a formation so large and complex that it shouldn't exist in the early universe. It suggested a large-scale cosmic organization far too soon after the Big Bang. The Standard Model was running out of options. From physics to philosophy, the mirror line and the hourglass. Let's imagine the cosmos as an hourglass. On one side, our universe, the one we know. On the other, a mirror image. At the narrowest point is the moment of interaction, where time and space may converge, or even overlap. That's where we may now be looking, through the neck of the hourglass, seeing the light not just from our past, but from somewhere else entirely. The galaxies at the farthest edge of our view, those impossible structures, could be ghosts from this mirror universe. The redshift isn't just a measure of distance or time, but distortion at the edge of reality, a quantum bleed-through from a parallel world. And if Schrödinger's galaxy truly exists in two places at once, then so, perhaps, do we. Conclusion: the crisis that could become a revolution. We are witnessing a collision between observation and theory, between the known and the unknown. For over a century, physics has been divided between the macro relativity, gravity, galaxies, and the micro quantum mechanics, particles, wave functions. These realms have never fully reconciled. But now, the James Webb Space Telescope, this marvel of engineering and vision, may be the instrument that forces a unification, or at least forces us to abandon old dogmas. Science is not dying. It is evolving. Like Galileo's telescope or Newton's apple, we are again on the edge of a scientific revolution. So what lies ahead?